When you get a cut, there's a whole bunch of bacteria that go from the wound into the surrounding tissue. At this point, the complement system, C3, starts to attack the invaders. It first splits itself into two smaller proteins, C3A and C3B. C3B acts like a homing missile, searching for a specific bacterial virus. But it only has a second. If it doesn't find its target, it'll be neutralized by water molecules. When C3b finds its target within a second, it anchors itself to the surface. At this point, the protein changes form again. The new form allows it to connect with other proteins to create new forms. And after a number of shapeshifts, to allow more proteins to attach to it. And eventually turns itself into a C3 transformation platform. It won't take long for thousands of proteins to coat the bacteria. They'll reduce the bacteria's activity and prevent it from sending out a distress signal. The other side of the C3A is sending distress signals all over your body. Passive immune cells notice these C3As and wake up from their dormant state and follow the C3A's path to the site of infection. Now the complement proteins have managed to call for help and stall the invaders. The first immune cells to arrive are phagocytes. They'll swallow the bacteria whole and then kill it with acid. But it's not easy to catch a bacteria. At this point, attachment proteins come into play. They attach themselves to the bacteria to make it easier for the immune cells to grab it. And the C3 transition platforms start to change form again. They become a membrane attack complex. The new protein C9 inserts itself into the bacterial membrane until it creates a hole that can't be repaired. And then, the inside of the bacteria starts to spill out. It's like dying of blood loss. The remaining bacteria are distracted or even seriously injured by the complement proteins. It's immediately cleaned up by the immune cells, and your invasion crisis is averted. The complement system is more effective against viruses than bacteria. They have to move from cell to cell. When they're outside the cell, they're completely defenseless. At this point, the complement proteins intercept and weaken the viruses and directs the immune cells to consume them. So why do we still get sick? Take the cowpox virus, for example. It forces the cell to make a protein that shuts down the complement system. In this way, the virus is able to create a safe zone around an infected cell. When the virus kills the cell, it can more efficiently infect other healthy cells nearby. Other bacteria can grab specific molecules from the bloodstream. This allows them to avoid triggering the complement system and thus achieve invisibility. The complement system is a member of our complex immune system. It's like a little bomb in your bloodstream. They're the most effective weapon against invaders. They've evolved over 700 million years and come in 30 different forms. And they're in your bloodstream all over your body. The immune system has many tools to activate the complement system. There are also a number of mechanisms that prevent the complement system from attacking indiscriminately.